Hey everyone, in this video we will be graphing the polynomial you see on your screen right now. Now, let's just put it out there. I'm quite aware that this is a quadratic trinomial and that most people will graph this using x equals negative b over 2a to get the vertex. We're going to graph this as under the broad umbrella of graphing polynomials. We're going to find x-intercepts. For one thing, if you did do negative b over 2a, or if you completed the square or whatever, to get the vertex of this particular parabola, your x value of your vertex is going to be negative 1/2. Then you would plug negative 1/2 back in by hand to figure out the corresponding y value. So then you're dealing with a negative fraction, you're squaring it, it's a lot. If we do it this way that I'm going to show you instead, it's a little bit better. We're just sketching. We're not finding the max or min. So you have to read the room. You got to know what you're doing. Like, what's your end goal? Are you just trying to get a sketch? Do you want the vertex? Do you just want to know what it looks like? That's on you. So read the directions, read the room, read the worksheet, read the everything, and figure out what the best approach is going to be. Okay? Okay. So I'm trying to get a better pen in my possession here. I'm running out of ink. So Consigno pens, get me some bold inky pens over here because I'm running out. Okay, so if we go through my procedure that I showed you, I would go back 2 videos. So the first one in the playlist where I give you all the details. So if you don't know local behavior, if you don't know my little mnemonic device to go through the steps, definitely go back to that first video. And come here, mister. What do you want to be held? This guy today. Here he is again. He's been in all the graphing polynomial videos. He is just looking for attention today. Okay. So thumbs up for Dal. So if you don't know those steps, go back to the first video. I'm not going to get into it every single video. First step we're doing is the E step in the mnemonic device. And the E is for figuring out our end behavior. So I'll scooch that over. End behavior, well, I'm going to look at the negative x squared for that, and that means our end behavior is down and down. Down on the left, down on the right. The down on the right is determined by the negative. So this is because it's negative. And the other down on the left side is because it's even, and when your degree is even, you have the same behavior on both sides. Next step, F, factor. Not going to get into the rant I got into the last video, but like, guys, put on your big boy pants and your big girl pants and factor out the freaking negative, okay? Stop leaving it in there. You are not a champion. You are prone to mistakes like everyone else. It's weird. Factor it out. Knock it off. Cut it out. So start with factoring out the negative. Inside, I'm left with then x squared plus x minus 6. Then the inside, I could kind of just glance at, and we could kind of factor in our head. It's going to be x and x. If you need to know how to factor, go watch my factoring videos. I have a whole playlist. I'm not teaching you now. 3 and 2. I need a positive 1 in the middle, so I got a plus 3, and I got a negative 2. Even if you're a weirdo and you leave the negative in, which I can't believe I'm entertaining if you do that right now. Stop doing that. But you should get the same x-intercepts, and if you don't, there you go. Case in point, you're messing up. Take my advice, okay? I've been doing this since God's dog was a puppy, and I can tell you, I know more than you do, okay? Just listen to me. So there we are. We're factored. And really, I guess I should have left the y equals in front. Okay. Next step is zeros for zero product property. So we're going to set each factor equal to 0. Now this negative is nothing to set equal to 0. It's a constant. It's a negative 1. But I can set the x plus 3 equal to 0, and that should give me negative 3. And I could set the x minus 2 equal to 0, and that should give you x equals 2. So those are your zeros from the zero product property, or my x-intercepts. Next thing is A, which is axes. So drew them already. I am done and ready to go. You want to make sure you have enough room to fit your x-intercepts. Never label your y. It's not worth it if you're sketching a polynomial. They're usually ridiculous numbers. Next thing is plotting and labeling, okay? So we're going to plot these, but label them with their local behavior as well as their value. So if I plot 2 and if I plot -3, I want to label them. I always label them underneath. So there we go, 2 and -3. Now their local behavior is determined by the little egg it came out of. Again, I explained this whole thing. It's not an egg, I know. I explained this all in the first video, which was in this playlist, which is y equals x cubed minus 4x. So it's probably linked below. It's in the playlist that this is in, the Graphing Polynomials playlist. So the whole explanation's there, local behaviors and this and that. So because these are both just to the first power, they don't have multiple, they're multiplicity. I mean, usually we use multiplicity if it's like a 2 or greater, but say they're 1, okay? So not multiple. That is going to imply a linear behavior. Please don't be confused. If you don't know what I'm talking about, stop being a baby, go back to the first video and watch it, okay? Like, you're not just going to miraculously understand. So linear, linear, I'm going to put a little L, I'm going to put a little L. Now, with the plotting and the labeling steps, I also want to tack on my down and down in behavior. So let me just grab a color pen over here. So down and down, I'm going to be facing down on both ends. And I'm going to work my way to these x-intercepts or zeros. I'm going to work my way towards them, and the L at each of them, they're both L, is telling me that I will behave linearly at that local point, that x-intercept. So linear, I'm going to slice pretty much straight through. However, polynomials are smooth, continuous, no sharp edges. So I really have to draw the whole entire thing out nicely. And it comes with practice. You cannot just watch me do it. It's like snowboarding. You can't watch someone do it and then just stand up and be a good snowboarder. You're going to have to fall down a few times, you know? So you got to keep trying and getting back up and make your way down that mountain, you know? So here, -x squared. Oh, also, if you're working your whole way through, what do we say about our insurance policy? We start on the right. So I work my way into the graph. I cut through linearly. I'm going to have to work my way towards this other x-intercept though. So somewhere I'm going to have to turn around. How high? I don't know. You pick and decide like what makes the most sense for you, you know, based on like the angle you're drawing it at and all that. I'm going to turn around. I know this looks like a quadratic behavior because it's quadratic, but on the x-axis locally, it does not behave quadratically locally at that spot. If I put just a spotlight, it looks linear. If I put just a spotlight and zoom in on just this part, it looks linear. This is what we mean, okay? So then again, we slice through linearly, and then my left side's end behavior aligns, so winner, winner, chicken dinner, you're killing it. So again, what were the steps? End behavior, factor, zero product property, axes, plot and label the local behavior, and then last but not least, we graph. That's it. There you have it. I mentioned in the beginning that if you graphed it sort of the more traditional way, that your x value of the axis or axis of symmetry would be -1/2, and you'll have a fraction and a negative, and most people are not fans when they have to do that by hand. They make lots of mistakes. So this way we got a nice little sketch going on. Beautiful. It's exactly what we need for the conversation we're having. So thumbs up for puppies in pajamas. Thumbs down if you're an animal hater. I mean, sure, I guess. Why? Click through for the next video, check the playlist, and comment any other suggestions, ideas, or tips you have for other people, because I'm sure that confused people and sad, stressed out people would appreciate it. Have a great day and see you next time. Bye.